So the first thing you want to see is what is x approaching. That's pretty important because that's going to tell you what to look for in your y value, which will be your limit. What is the y approaching as x approaches? So x is approaching 0 here. So I am going to say, well, where is x 0? Well, x is 0 right here. This is just a parabola. There are no issues, right, whatsoever. So I am literally just going to say, where is my y moving? From the left-hand side, from the right-hand side, it is moving to the same number. That means I do have a limit, and my limit is the number that it is going to, which is the number 2. All right, if there had been a hole there, it would have been the same limit, right? If they were going to 2 different things, I would not have an overall limit. And so that's literally all you're doing when you have a graph is, what is y approaching as I'm getting to the x that they want me to get to? So like for this one, I'm going to do this exactly the same way. It wants to know what is y doing as x approaches -2. So I'm going to find -2 on the graph, right? It doesn't matter that this is a piecewise. From the left-hand side, I'm approaching the same number that I'm approaching from the right-hand side, and it is this number right here, which is -3. That is my answer. All right, for this one, it says, given the function, and they give you a function in the question, find delta when epsilon is 0.01. All right, so the first thing you want to remember is that definition. The definition is that you have some function minus your limit, and that is less than an epsilon. And what you're trying to figure out is, if I take my x minus my constant, the number that x is moving towards, it is going to be less than some delta that corresponds to it, all right? And so we want to figure out what all we have. Well, this is my f of x, this is my limit, and this is my c, okay? And so I'm just going to plug those in. My f of x, well, that is 2x plus 5, minus my limit, that is 3. That needs to be less than the epsilon that they gave me, 0.01. Now I need to try to make this look like x minus c. Well, c in this case is -1. And when I get it to look like that, I will have figured out what my delta is. So basically, I want to try to get this to look like x plus 1. And then whatever I have over here on that less than side will be my delta. So I'm going to simplify the inside of my absolute value. So I have 2x plus 5 minus 3 is plus 2, is less than 0.01. How do I make it look like x plus 1? What do I need to factor out?
2.
I need to factor out a 2. And so I'm going to pull a 2 out. I have the x plus 1. My final step is to divide that 2 over. So I want to divide that 2 over. And this is very similar to the example we did yesterday, which means this is my delta. If I want to get 0.0 away from my actual limit, I need to get 0.005 away from my actual x value of -1. When you see evaluate the limit, the first thing you want to try is you want to try to just plug in the limit. Plug in your c value and see if you can do it. If that doesn't work, you want to say, well, maybe I can factor my functions and cancel out my problems, right? If you have a radical, you're likely going to have to rationalize, which means multiply by the conjugate. And so these are the 3 methods so far that we have done. I would always start with the easiest, which means see if you can plug it in. Even if you have a denominator, you want to first see if you can plug it in. Just because you have a denominator doesn't mean you're going to have to factor. You're only going to have to factor if your denominator is going to be a 0 when you plug it in, right? So always look to see if you can plug it in first. In this case, obviously, if I want to evaluate this limit, I'm just going to plug it in, which means I'm going to take that 2 and just plug it in. Negative 2 times 2 plus 5, my answer here is 1. That is my limit. I can see on number 21, plugging in a -1 gives me -1 plus 1, which gives me a 0. That is a problem. I cannot do my first process. So my next step is I'm going to factor. This is really simple factoring. So I am trying to find my limit as x approaches -1, and I'm going to factor this. X minus 3, x plus 1, all over x plus 1. Now that I've done it, I can eliminate my problem. And I can just find the limit as x approaches -1 of what is left over, x minus 3. Now I go back to my first process, which is plug it in. I can simply plug in a -1. -1 minus 3 is -4. And that is my overall limit, -4. The next few are actually trig, and these are the ones you have to memorize. Remember, and these are just the two that we had. The limit as x approaches 0 of sine x over x is 1. And the limit as x approaches 0 of 1 minus cosine x over x equals 0. All right? If you have anything multiplying those, you're going to multiply them by either 1 or 0 because you can factor it out. So let's say I had 3 sine of x over x. Well, that's going to be 3 because it's 3 times 1. If I had 1 minus cosine of x over 3x, that's going to be 0 because if I factor out a 1/3, I'm multiplying it by 0 when I finally get done with those. So if there's any coefficient, you can multiply by what that limit would be. Or if it's just like this number 23, that is just 0. All right, so for the last one, plugging in causes a problem because I get a 0 in the denominator. I can't really factor because none of them are factorable. So then I'm going to use that third method, which is rationalization. And so I am going to multiply the top and bottom by the conjugate of the one that has the radical. So top and bottom here, and remember conjugate is just this exact thing, changing the sign of the plus or minus that's outside of the radical. On the top, I'm going to leave it alone. I'm going to leave it as x minus 3, there's a minus, times the square root of x minus 2 plus 1. On the bottom, it is like the a plus b, a minus b. Anytime you multiply conjugates, you square the first one. Well, when I square a square root, I get what's inside, minus the square of the last one. 1 squared is just 1. This is going to simplify to x minus 3, which means I can now cancel x minus 3 and x minus 3, which means I got rid of my problem. The limit as x approaches 3 of the square root of x minus 2 plus 1 does not cause a problem when I plug it in. I can now just plug it in. And so I'm going to take the 3 and plug it in. I have the square root of 3 minus 2 plus 1. The square root of 3 minus 2 is the square root of 1, which is 1 plus 1. My limit here is 2.